Yesterday we simplified radicals by rationalizing either denominator or numerator. We also simplified by reducing the order of index. Do we have any questions on any of those type of problems? Tim?
Yeah, on page 45 on page,
Okay. Problem number 45 on page 162?
Yeah, 162.
Okay, let's take a look at that. 45. It says 1 over the cube root of x squared. Now what we have to do is we have to rationalize that denominator. Now, we want to get everything out of that radical. We don't want any radicals in the denominator. So we're going to multiply by 1. 1 will be the cube root of something over the cube root of something. Okay, Tim? Now, how many of the same factors do we need in order to bring one out of the radical? How many of the same? What does it say? No. Listen to the question, Tim. How many of the same do we need in this particular problem in order to bring it out of the radical? 3. Okay, we need 3 of the same identical factors to bring one outside the radical. And that's what we want to do. We want to get everything out. So how many x's do I have, Tim? 2. How many more do I need? 1 more. So this is what we're multiplying both numerator and denominator by. So our numerator, well, 1 times the cube root of x is the cube root of x. Denominator, the cube root of x squared times the cube root of x is the cube root of x cubed. What is the cube root of x cubed? What is the cube root of x cubed? What's the square root of x squared? What's the square root of x squared?
X.
What's the cube root of x cubed?
X squared.
No.
X3.
No.
X.
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 Sure. The 5th root of x to the 5th, x. The 10th root of x to the 10th, x. The nth root of x to the n is always x. You see, you take this out of radical form, you get x to the 3 over 3 power, which is x to the 1st. So you have the cube root of x over x is your answer. Number 45. Okay? Any other we had trouble on? Okay. Today a nice day. Interesting day. Easy day. Today we're going to talk about multiplication of radicals. Multiplication of radicals. Well, we already have a property for that. Our property says that the nth root of a times the nth root of b is equal to the nth root of ab. That was one property we had in multiplication. Another property we had in multiplication was that the square root of a times the square root of a will give you a. These are the 2 properties we have. Now, all we're saying there is the square root of 3 times the square root of 5 is going to equal square root of 15. Okay? Because that's what property says up here. Anytime you multiply 2 radicals, they must have the same index, then you multiply the radicands. Now, what we did there is we multiplied a 1-termer times a 1-termer, monomial times a monomial. So what we're going to do now is multiply a 1-termer times many terms. Example. Let's suppose we have the square root of 3 times a quantity, the square root of 7 plus the square root of 2. Let's multiply them. The square root is 3 times a quantity, the square root of 7 plus the square root of 2. This problem should take you matters of seconds. Matter of seconds. Help. Who has an answer? Wong?
Square root 27.
No. Tony?
Square root of 21 plus the square root of 6.
Yeah, you can't add those. They're different. We already know how to add. What we're doing is we're multiplying. Square root of 3 times square root of 7 is the square root of 21. Plus, square root of 3 times square root of 2 is the square root of 6. We can't add these. They're different labels. You can't add x to y's. This is your answer. Okay? Knowing that, let's try this one. Let's suppose we have 2 times the square root of 5 times 3 square roots of 3 minus 4 square roots of 2. Again, this should not take you long. Wong, let's see what you do in this one.
Okay, 6 square root 15 minus 8 square root 50.
8 square roots of what?
50.
No.
Oh, 10. I mean,
Yeah. Yeah, this is arithmetic.
actually,
Here we go. We're multiplying this times every single term in the parenthesis. So we're multiplying this times the first term. We take care of the coefficients. 2 times 3 is 6. Square root of 5 times the square root of 3, well, that's the square root of 15. And there's the first term. We now move down to the second. Well, that's a negative. Coefficients, 2 times 4 is 8. Square root of 5 times square root of 2 is square root of 10. That's it. Don't make them difficult yet. Let's suppose we have this. 7 square roots of, let's see, 11 times 3 square roots of 6 minus 2 square roots of 7. Okay, Michael, what'd you get for an answer for this one?
21 square roots of 66 minus 14 square roots of 77.
Very good. Right. What we're doing here is multiplying 1 times many. A monomial times a polynomial. So, it says 7 square roots of 11 times 3 square roots of 6. First thing we do is take care of the coefficient. 7 times 3 is 21. Square root of 11 times square root of 6 is the square root of 66. And there's the first term. We're now going to multiply 7 square roots of 11 times a negative 2 square roots of 7. Well, that's a negative. 7 times 2, the coefficient is 14. Square root 11 times square root of 7 is square root of 77. And there's the answer. Okay? Let's try this one. Square root of 6 times a quantity, square root of 3 plus the square root of 2. Okay, this should be interesting. What do we get for the answer here? Help. Tony?
3 square roots of 2 plus 2 square roots of 3.
Very good. 3 square roots of 3 plus 2 square roots of 2. Let's see how we got it. 2 square roots of 3. Is that what you said?
Yeah,
3 square roots of 2
Okay, yeah.
plus,
2 and 3.
yeah. Here we go. We multiply this, we get the square root of 18 plus the square root of 12. But we learned before that anytime a radical can be simplified, it must be simplified. So we have to simplify this. Well, 18, you know how to simplify. 3, 3, and 2. We can take out a 3, so we have 3 square roots of 2 plus 12 is 2 times 3. That gives us 2 square roots of 3. And that's what Tony said the answer was. Remember, the multiplication is very, very trivial. But you have to simplify each radical. Make sure it's simplified. So let's take a look at this one. Let's suppose I have square root of 5 times the quantity, the square root of 10 minus the square root of 5. Okay, let's take a look at this problem. B, we're going to multiply. The square root of 5 times the square root of 10 will give us square root of 50. Minus square root of 5 times the square root of 5 is
Square root of 25.
Yeah, but we had a property. Right. The square root of a times the square root of a is always a. We don't need that step anymore. So that's just 5. Now we have to simplify 50. Well, that's 5 times 2. We can take a 5 on, 1 5 on. So we get 5 square roots of 2 minus 5. Okay? Let's try this one. 4 square roots of 3 times the quantity, 2 square roots of 15 minus 7 square roots of 3. That's 4 square roots of 3 times the quantity, 2 square roots of 15 minus 7 square roots of 3. Okay, let's take a look at this problem and show you how nice and easy this problem is. Tim, I'm at you. We're multiplying the first term, 4 square roots of 3, times the first term in the parenthesis, which is 2 square roots of 15. First of all, the coefficients, Tim. 4 times 2 is?
4 times 2 is 8.
8. Times the square root. The square root of 3 times the square root of 15 is?
3.
3 square root of 3. 3 times 15.
Oh, that's 45.
45. So there's the first term. Now we move and multiply the second term. The coefficients. 4 times 7.
Times 7 is
28. The square root of 3 times the square root of 3. 3. So there it is. Now remember, anytime a radical can be simplified, it must be simplified. 45 is 3 times 3 times 5. We can pull a 3 out. We already have an 8 out there. So that's a product. 3 times 8 is 24. Inside we still have the square root of 5. Minus 3 times 24, that's 80. 28 is 84. And there's the answer. Okay? Let's try this one. 7 square roots of 2 times the quantity. 2 square roots of 14 plus 9 square roots of 2. Okay, Kathy, you have an answer.
28 square roots of 7 plus 126.
That's it.
What would be square root of 2?
Yep. That should be it. Okay, let's find out. We're multiplying each term in the parenthesis by 7 square roots of 2. So the first, 7 times 2 is 14. The square root of 2 times square root of 14 is the square root of 28. There's the first term. Second term, plus. 7 times 9 is 63. The square root of 2 times the square root of 2, Tim, is
2.
2. That's the importance of that property I gave you. So that's what we have. We simplify 28, well that's 2 times 7, we can extract the 2. We already have a 14 out there, that gives us 28. Inside we have square roots of 7. 63 times 2 is 126. Okay? Now what we were doing there was multiplying a one termer times many terms. Monomial, polynomial. So what that leaves us is a polynomial times a polynomial. Many times many. Well, let's take a look. This is 3 square roots of 5 plus 2 square roots of 2 times the quantity, 4 square roots of 5 plus 3 square roots of 2. And it says multiply those two terms. What is the key word there? Yeah, what's the magic word though? How you gonna do it? Think, how you gonna multiply that? That's what it is. The magic word is FOIL. Okay. Kathy,
Don't ask.
don't ask. What do you have, Kath?
720 times 72 times square root of 10.
Nope.
Oh, it's not that.
No, you're right. Well, let's take a look at this problem. It's FOIL. FOIL, Cap. FOIL says first times the first. Well, 3 times 4 is 12. The square root of 5 times the square root of 5 is 5. So for the first term, we have 12 times 5, which is 60. Now we multiply the outers. Coefficients, 3 times 3 is 9. The square root of 5 times square root of 2 is square root of 10. We multiply the inners. 2 times 4 is 8. Square root of 2 times square root of 5 is square root of 10. We now add those. If I add these, I get 17 square roots of 10.
Okay.
All that leaves us now is the last times the last. 2 times 3 is 6. The square root of 2 times the square root of 2 is 2. So for the last term, we get a positive 12. We're done multiplying, but we have to look to see if there are any terms you can combine. Well, the 60 and the 12 is 72 plus 17 square roots of 10. And that's the
Taking
answer.
the adding stuff and multiplying.
Yeah.
Yeah.
Okay, now that you know what to do, let's everybody get one right. Let's see. 6 square roots of 3 minus, let's see, 5 square roots of 2 times 7 square roots of 3 minus, let's make it plus 4 square roots of 2.
I have it written here and copied it all.
Okay.